Okay. Before we do anything, I want to just give you a straight fact, which is that when logarithms were first developed, it was based off of the idea of 10 as a base. When we talk about base 10, we refer to that as the common logarithm. And because it was slightly the original logarithm that was developed, instead of writing log base 10 of x, we can just simply write log of x. When you see log of x, it's an assumed base 10. Here, I've gone ahead and given you the graphs of y equals 10 to the x and y equals log base 10 of x. So even if you remember nothing about last Friday, in a most ideal world, you should look at those and know they are related how? Why?
Because they reflect across the thing.
When I draw the line y equals x, I can see that they are reflections of each other. Now, what we're going to do is go through the process that we've done honestly at least 10 times, where we start with my original exponential, and we quickly create the table that goes along with it. What runs down that x column?
-2, -1, 0, 1, 2.
Perfect. And I think it helps to, because eventually you're going to do these without a calculator, I think it helps to make it, to start with 0. 10 to the 0 is 10 to the first is 10, and this is 100. Why would I do these first? Because then I can see that -1 is simply what?
1 over 10.
Yeah, just the reciprocal. Similarly, that's 1/100th. And for at least the 10th time, what is the domain of this?
All real numbers.
Negative infinity to infinity, the range is
0 to
the horizontal asymptote is,
1 equals 0.
and the y-intercept is
1.
0, 1, right? Make sure we give it as an ordered pair. Now, our job then is to recognize that my exponential function here will have an inverse. And we know from our Chapter 6 test, which you saw those scores go in last week, and I've got one more person, well, actually 2 more people, who are finishing up, so you'll get those back this week. When I find my inverse, I do what to begin with the original? Flip the x and y. Now, this is where you got to reference what we did on Friday. I flip the x and y and solve for y. Okay. Do you remember the phrase I had you say a bunch of times? A logarithm is an exponent. So what we do is we go from the exponential form to the logarithmic form by remembering that my logarithm is the exponent. It's the log of x, and in this case, base 10. That's both the exponential and logarithmic form of the same thing, of the inverse. So, technically, I'm about to create a table here, and that table is both of these, but we're going to simply reference it as log base 10 of x. Now, from red table to blue table, I just what? Flip them, right? Now, pause for a minute and look right here. I'm going to tell you that 75% of kids who learn this are going to cling to find the exponential first, find the logarithmic second. That is completely fine. But I'm also going to start teaching you how to just find the logarithmic points. So listen, because we're going to practice this now and really practice it tomorrow. I know that my y values have to be my exponents. Why? Because they were my inputs before, so they're my outputs now, and a logarithm is an exponent. So I know that the exponents from before are the y values now. So one way to find the x values is to think about putting, you'll want to watch my finger pointing here, putting things like the 0 in. So if I put a 0 in for y, this would say 10 to the 0 equals what? 1. If I put a 1 in for y. Can you see over there? 10 to the first equals what? 10. Now, what ideally you are starting to notice, however, is the x's are my powers of 10. Who kind of sees that? You don't have to see it great yet, but you at least see the gist. Okay, now, if some of you are like, can't I just flip the points? Yeah, you can just flip the points. It's going to make life easier, though, the faster you can see that way of thinking. With that said, we know from, hopefully, both Chapter 6 and on Friday, what is my domain?
0,
Why?
because it's forward.
It just flip-flop them. What's my range? Yes. I was going to ask it differently, but yes. Does my horizontal asymptote stay?
No.
No. It becomes, if you heard what Brody said, my vertical asymptote. Where? At x equals 0. Now notice this. In a most ideal world, you see, hey, look, I had a horizontal asymptote at y equals 0. If I reflect that about the line y equals x, what happens? It turns vertical. Okay? What about my y-intercept? It becomes an x-intercept, and that will be at 1, 0. I want to point out the processes, and then you're going to repeat the processes. First, we found a table of the exponential characteristics. We technically, algebraically found the inverse. Then we found the table for the inverse and the characteristics. If you're totally fine with that, raise your hand. Okay, so go to the bottom slide. There are 2 functions there. Name them. Just say them out loud for me. Y equals 0.5 to the x and? Okay, so I just labeled them on this slide like this. And now you're going to go through the exact same process. Now, the more you talk through this, the better off you're going to be. So,
Please try again in a moment. Thanks, Sarah.
so you're going to go like this. Let's go that group of 4 right there. Catherine Grace, you see yourself right there, that group of 4. You're going to go group of 4 right here. Okay. Brendan, will you swing around and let's go with Dennis and Brianna and Julia. Okay. Joe, you're going to go with Jackson and Allison and Ella. Just please over there. Miles and Lydia, you're going to go with Phoebe and Juliana. Okay. Lindsay, you're going to go with Amin and Joy. And then Beverly, you're going to go with Ava and Brody and Nick. And then Ethan, just, I'm going to put you in a different group. Hang on. Okay? Okay, go.
Right here.
Will you focus right there?
They are inverses of each other.
Thanks, Dennis.
Making it easy.
I think you're all here. Okay, so I liked it better when you were loosely talking with each other. So will you name your tables? What is your table for 0.5 to the x? Then name your characteristics.
One should then be 0.5.
Yeah, so it's 2. Because like 0.5 is 1/2.
Yeah.
Certain length, and then it's 2.
Because everything
The inverse. So,
Yeah, I
but-
went to do both of them.
isn't this one right here?
So, negative one would be 5.
So it should go -2, 4, -0, 1, 1.5, 2.
Is that good for the
Okay, that makes sense.
This one's going low.
Well, yeah, I mean, if we put these in the inverses, kind of take one of their weights, 1 to 1.
This many.
Yeah.
I'm not taking a quiz with during office hours. Like, is there people?
Yeah, there are. Oh, you coming after during office hours?
I went to math lab, but this one's a little more confusing because I missed more.
Miss me. Are you ready to decimals and fractions?
No. Hey, I'd prefer that you be in fractions, primarily because when you have no calculator, you're gonna depend on the fractions, not the decimals.
Like I tried doing homework circus, so it's just like,
Hey, we do you a favor.
yeah.
So I'm going to
Yeah.
write this.
Right.
Go to
I don't know about
219.
that one.
Then,
It was a recent one. There's the one before.
Oh,
Yeah.
Yeah, that's the one.
Oh yeah. Second guy is brutal. We're actually supposed to be talking as examples. Oh, I'm sorry.
Yeah.
Okay, if you're done, raise your hands. Okay, so will you quickly please check? Will you quickly please check those tables? On the left, in the middle is where we algebraically found that inverse. On the right are your actual x and y values for your log. Now we'll continue to talk more and more about those two shapes, but let's be clear. Talking about the exponential. I'm going to go a little faster. Are you ready? We're talking about exponential only. Domain. No, domain. Negative infinity to infinity. Range.
0 to infinity.
Horizontal asymptote.
Y equals 0.
Y-intercept.
0, 1.
Okay, so when we take and find the logarithm, the domain is,
0 to infinity.
everybody, let's go. Range.
Negative, positive.
Does it have a horizontal asymptote?
No.
It has a where?
X equals 0.
Does it have a y-intercept?
No.
Where's the x-intercept?
1, 0.
Okay. Now, why are those characteristics like that? Because a logarithm and an exponential, what kind of functions are they? Inverses. So if I say, hey, what's the inverse of an exponential? You say what? A log. So look at the bottom question. What's the inverse, therefore, of a log? Exponential. Why? Because we created it to be that. We had exponentials. We talked already about how they apply in real life. We need to be able to solve, for instance, for time and certain exponents. And so how do we do that? We do that by way of logarithmic functions. So with that said, and keeping with this idea, I want you to look at the next slide. We need to be able to, for sure, make this connection, look at the bottom slide there, please, between the two graphs always. So you literally just said this to me. I'm going to give you a minute just to have it in your notes officially. This is literally what you just repeated back to me. So when I deal with exponential and logarithmic functions, I want to constantly think of them as inverses. And then I can depend on knowing the characteristics using that concept. I also can depend on it just simply because I know how exponentials in particular work. Okay, if you need more time, raise your hand. But another way to ask these questions is listed there at the slide at the top. If I give you y equals log base 2 of x, this is clearly a logarithmic function. If I said, what's the inverse, don't give me a specific answer. The inverse of the log is n. Okay, now, you might be able to, without really any effort at all, give me the inverse of log base 2 of x. If you think you can do that, raise your hand. We got 1. Good. 2, 3. Okay, share with your groups really fast. Go.
I got 2.
Okay, Beverly, what's that answer? Okay. So I hear that all over. My inverse is y equals 2 to the x. Now I'm guessing you basically get that, yeah? Okay, but I'm going to algebraically show you how you need to think through this. So for the record, I prefer what you just did. I prefer to give you a log and for you to just see that it's that. But they're going to get harder and seeing them won't be as easy. So we're going to depend on our algebraic process, which says, what do I do if I want to find the inverse? I first switch x and y and solve for y. How do I solve for y? This is not really the Snell method, but it's something like it. I take 2 to the x to get y. That definition of log, which is, especially tomorrow, what you're going to hear me say a lot. That definition of log says 2 to the x equals y. That base to the number outside the equation sign symbol, the equal symbol, is that inside input number. Now, do I want you to do that for something this easy? No, I do not. But you're going to have to do it for the next one. So I want you to find the inverse in your groups of y equals log of x minus 4. For the record, what base is that? 10. Go.
Because there's a
I don't know.
because it's
I switched their spots, and that gives you x equals log 10 parentheses y minus 4. And then I did the reverse of the log, which is 10 to the power of x equals y minus 4.
All right, if you found that inverse, tell me how to do it. I'll take a volunteer. If I've got y equals log of x minus 4, what do I do to find the inverse, Dennis?
Well, the first one would switch the x and the y,
Yep.
and then you would reverse the log, which would give you
I like it saying that way. Yeah.
10x
10.
equals, 10 to the power of x equals y minus 4.
Okay, somebody else. Is that done? No. Why not, Grace? So I got y equals. Okay, now that should clue you in, and I'm going to mention this now, and then we're going to get to it. That gives you a hint that if we can take an exponential and shift it up, down, left, or right, which we have done, and you did on your quiz on Tuesday, then as you can imagine, we can do that to our logarithms. Before we do that, however, we have to be able to have an original graph of any log. So, with that in mind, look at your next slide. Here, you're given a new base. Y equals log base 3 of x. Now, I'm going to, again, stress 75% of you will do best if when I say, hey, graph this log, it's going to help you if you actually graph what first? The inverse, which is 3 to the x. Now listen, by now, cranking out this table should be really fast. X's run from what to what? Okay, 3 to the negative second is 1/9. This is 1. This is? Okay, if you're not fast with that now, you've got about probably 3 school days. What's the domain? Yep. What's the range? What's the horizontal asymptote? And the y-intercept. Okay, so I've already given you the picture, but what I want you to notice is now we're able to come up with those ordered pairs by way of the inverse so that when I go to graph this, my ordered pairs just simply what? Switch. Now, if you like that, raise your hand. Okay, if you want a quicker way, raise your hand. Okay, run. Yeah. So, am I talking to anyone besides Brody?
Well, is it easier or just quicker?
It's mostly quicker. I would say this is probably, using the inverse is probably easier. Okay, so who am I talking to besides Brody, just so I know? Okay, so like 4 or 5 of you. Okay, so if you're good to go, run with it and start plotting. Like, start getting your actual table and characteristics. For the other people, I think of it as putting in my powers of 3. I know my powers of 3 end with 3 and 9. I know that they go back to 1, and then I take their reciprocals. And I already know that these are my exponents. So notice, I didn't need any of that. Okay? Okay, finish that up. When you're ready, just check up here. One thing I'm hoping you're at least starting to appreciate a little is realistically, you probably don't even have this great understanding yet of a logarithm, and yet using everything you know up through this point in Algebra 2, you're able to take this kind of obscure feeling function and graph it, which hopefully that should feel like a decent, cool thing to be able to do. Check your domain, your range, your vertical asymptote, and your x-intercept. Okay, one other quick comment. Just like with horizontal asymptotes and exponentials, where you make sure that you've included your vertical asymptote on your picture. Include that vertical asymptote. Here's 1, 0. Here's 3, 1. You can easily see 9, 2. Notice it's not just these connectors. It's the entire graph going in both directions. So, with that in mind, on the next slide, you have log base 4 of x. Now listen to what I want. However you want to get it. If you want to get it by way of finding the inverse first, awesome, run with it. If you want to try that method I just talked you through, run with that. When I ask you for a logarithmic graph, I am asking you just for the logarithm. If you need the exponential in the meantime, that's fine. Just make sure it's dashed. I want the ordered pairs and the characteristics of specifically the logarithmic graph. Go.
How do we find the y-intercept in the logarithm?
Well, you tell me.
What one?
Plug in.
Is that log?
Well, you plug in 0 for
Or is
what?
that like log 4?
Why?
For what?
I don't know.
And here's what you should notice. If I have a vertical asymptote there, is it what kind of not?
The y-intercept is not.
But exponentialize.
Randomly, what you get, bud?
Why is it? Now, we want to pay close attention to this logarithmic table because we're going to use it on this slide and on another slide.
Are we gonna do anything other than notes today?
Do you mean, do we get the privilege of doing notes today, the whole period? Yes. Isn't that so good?
Really appreciate that.
Yeah, I'm here for you. Tomorrow we're just going to put it all together and just read lots of practice time. What should the y values of the logarithm run from? The y values of the logarithm run from -2 to 2. You're welcome to do it that way.
Let's make a table too.
Yes. Table characteristics and graph.
And
Ooh, it's a graph.
Yeah, only it doesn't say that. I'm asking you to graph it.
What do you want us to grab it?
Just sketch it.
Where is the table?
Table characteristics graph.
For the inverse or the regular?
Well, I really just want the logarithm.
Oh.
So if you use the inverse to get the logarithm, that's fine. But when I ask you for a logarithmic graph, I will never grade the inverse.
So are we graphing the logarithm or
You're graphing the logarithm because that's what the question asks. Now, to say that again of what I just said to Jackson, you might personally graph the exponential first, and that's fine, totally fine.
and then we can
Like-
do that.
Yes.
The only reason you make this one is just the flip.
That's true. It does.
Yeah, but like first you can do this.
Go ahead, Lydia.
Not the inverse of that. Like where the
Oh, that's. Is this the inverse of that?
the range might be
Oh.
like the opposite of the
No. That will always be true of inverses. Okay, now we're about to list the characteristics of the log. And then we're going to look at the graph. Ideally, we're starting to get pretty good at this. What is the domain of the log?
Zero
zero
to
to infinity,
What is the range?
negative infinity, infinity.
Okay, what is there a horizontal asymptote?
No.
But there's a vertical asymptote at,
X is 0,
and the x-intercept is?
1, 0.
Okay, now, in a minute, we're going to shift all of that. But for now, will you just really quickly look? For me, because I know some people do better, I went ahead and showed that exponential table. I also graphed the exponential, but what kind of line did I use for that? Dotted. If you draw me a solid exponential, you'll lose points. Okay?
Why?
Because that's not what I'm asking you to graph. So then I don't know the difference. I don't know if you know the difference between the exponential and the logarithm. Okay? But if you do a dash, I'll always give you credit for that. As long as the logarithmic is accurate. Okay, now that all said, look at the next slide. This is how we're going to end class today. We are going to begin just like with exponentials, where we move them left, right, up, and down. We're about to do the same here. But when we take log base 4 and do x minus 3 and then tack on 4 at the end, before we do anything else, we want to reference the parent points of log base 4 of x. Now, what are the parent points of that? Literally, what you just did. If you need to flip,
negative 1.
where does that go?
The X.
No,
The Y.
in the y. Good, that was a 50-50 shot. You adjusted nicely after that. If I go -2 to 2 in the y's, and my x's are powers of 4. So you can see how this becomes a big deal if you can start to transition to this. So this right here, 4 to the 0 is 1. This is 4. This is 16. This is these are the reciprocals going backwards. Now, again, just reference back to the previous slide. Those are the points you have. But now we need original graph based on those transformations. Will you raise your hand if you got an idea? You got an idea. Okay, really quickly in your group, see if you can come to an agreement. Go.
Well, it's moving up forward and it's transitioning to the right by 3.
Okay, so I hear this everywhere. Definitely up 4.
Yeah.
Okay, but I heard conflicting ideas on X. What does it do to 3? Right 3. Why? It's opposite of what you see. Okay, now, before I graph anything, I think it helps to just go ahead and let your points undergo this process. If my -2 to 2 goes up 4, then -2 must be at what? -1 must be at what? 0 must be at 4. 1 must be at 5, and 2 must be at 6. Notice these go in sequential order the same way these do. And then by far the harder part for people is always the stuff with the x's. Where does 1/16 go if it goes right 3?
3 1/16.
How about 1/4?
3 1/4.
Now be careful here. What about 1, 4, and 16? Okay. We're going to plot these in a minute. But do you see what we've done just numerically with the y's and the x's? I mean,
For like 3 and 1/16, should we like,
estimate.
should we like put it into fraction? Like,
Well, keep in mind, I'm going to be able to give this to you on a non-calculator. So I don't want you to turn that into a decimal.
Yeah.
And honestly, you're going to graph it, but let's be honest. You're just going to go to 3 and a teeny bit after it.
I mean like 49 over 16. instead
No,
of-
don't do that. Keep it 3 and 1/16. Yeah.
Are we allowed to have mixed numbers?
Yeah, that's basically what he's saying. I'm telling you, yes, keep them as mixed numbers. Otherwise, like if you turn it into what he's saying, like we don't even know where to graph that, right? It doesn't mean anything to us. Whereas 3 and 1/16, it's just a teeny bit arbitrary. Okay. Okay. So we're gonna sketch this graph, and then the very last thing we're gonna do is list the characteristics. So I've got my original 1/16 -2. Go ahead and start to plot these. Again, this is just a sketch. 1 0 4 1 16 2. This is not the original, or I'm sorry, this is not my end result. So notice I use a dashed line there.
Is that the paragraph?
That's the parent, yep. And then, if you've drawn a decent sketch, notice it's not perfect, it's okay. But when I go to graph 3 and 1/16 2, 3 and 1/4 3, 4 4, I start to get out here 5 6 7 5, and then 19 6, which is way out here. I should start to see some of these details. Now my graph still isn't perfect. You'll see why here in a minute. Yeah.
Do we have to do the parent function every single time? Is
I'm going
that-
to tell you yes. Now, did I do the inverse function here? No. No. But yes, you need to do the parent.
So, but do we have to ... it, or would the
Yeah, don't make it solid.
no? Do we have to graph it,
Oh.
or would the table
The
suffice?
table would suffice.
Okay.
I'd be fine with that. Okay, so last thing we're going to say. We're going to talk about the parent graph itself, the blue graph. What is the domain? Be careful here. 0 to infinity, right? Because now my parent is my logarithmic graph base 4. What is my range? Okay. What time do I have till?
33.
Oh, I got so much time. Horizontal asymptote. Horizontal, oh, sorry, vertical asymptote. You're right.
Yep.
What is it? Yep. Hey, stick with me here. And my x-intercept is 1 0. Okay. For the parent, because the parent is the log. Okay, so now, if we go to the red, what is the domain? Under a shift up 4, right 3, will the domain change?
No.
Yes. What will it be?
3
Three.
to infinity.
to infinity, right? If before, and you can see in a minute, you'll see that my graph isn't perfect here. If before I couldn't start to 0, well, if I shift all of that to the right, well, now I can't start till 3. Okay, if the range was negative infinity to infinity, will that change? Nope. No. Not. Will the vertical asymptote change?
Yes.
Yeah.
So what? X equals?
3.
Okay, now my graph stinks here in terms of accuracy, but make sure you put that on your graph. It should run at 3. So if I had a good graph, you can see it ran at 3. What about my, now this is the last thing. Are we okay with those 3?
Yeah.
What about my x-intercept? Do you see my x-intercept there? Does my table tell me where it hits the x-axis? No. So for now, we are not, we'll talk actually later in the chapter on how to find that.
You just put in 0 for 1.
Okay, just
Yeah, but I have to, no, 0 for,
That's not what it is.
oh yeah, no, 0 for y, but I haven't taught you how to solve yet.
Do this back.
Okay, so, hold on. Yeah. Okay, hey, zip it. Listen, please. Shh. Hang tight, real quick. Your assignment is from the worksheet you got last week. It's from section 7.3. It is only 7 problems. The first 3 ask you to graph. I want you to sketch them, just like we did just now in our notes. But I do want the points, the tables, as well as the characteristics. So, then the last 4 are really fast. They won't take you but a minute or 2. Okay? Okay, we good to go?
It's 6 problems.
It's 7, but yeah.
6.